This is a 5-minute review of balancing chemical reactions from the class Intro to Chemistry, and I'm Fred Oakes. Chemical reactions must be mass balanced. Let me give you an example of aluminum reacting with oxygen gas to form aluminum oxide. There's one aluminum on the left, but two on the right. And in fact, the oxygens also have fewer on the left than the right. That's a problem. Reactions must have the same mass on each side. They must follow the law of conservation of mass. Therefore, they must have the same number of elements on each side. So how do we do that? How do we mass balance? Well, one possibility would be to change the subscripts. Let's do two examples of that. On the left, I've changed the subscripts in the reactant side. On the right, I've changed the subscripts on the product side. Both of these reactions are now mass balanced, but they're also incorrect. For example, Al2 is not a simple metal, and O3 is ozone, not oxygen gas. AlO2 is an ionic compound that's not charge balanced, which can't happen. Neither of these two answers can be correct. So we can't change the subscripts. If we can't change the subscripts, what can we change? We'll put in front of each thing coefficients, putting whatever numbers are required so that we have the same number of elements on each side. Let's use this reaction as an example. We'll draw a table below it and keep track of the elements on each side of the reaction. We'll also keep track of how many of the elements there are. There's 1 aluminum and 2 oxygen on the left, 2 aluminum and 3 oxygens on the right. Now we'll put in coefficients to balance it. We'll start with aluminum. Let's put a 2 in front of aluminum. That changes the aluminum to 2 on the left and now balances it with the right. How about oxygen? Well, 2 and 3 are both common factors of 6. So let's get 6 oxygens on the left and on the right. To get it on the left, we put a 3 in front of O2. Now we have 6 oxygens total on the left. To get 6 on the right, we put a 2 in front of Al2O3. But not only does that 2 affect the oxygen to make 6 oxygens, it also affects the number of aluminums. We now have 4 aluminums on the right, which means we have to go back and rebalance the aluminum. That's no big deal. We'll toss out the 2 and put a 4 there. Now we've balanced the left and the right, and they're the same number of atoms on each. Let's do another example. Again, we'll start with the table and keeping track of the elements on each side of the reaction. We'll count how many elements there are on the left and how many elements there are on the right. Starting at the top, let's start with hydrogen. Easy enough, putting a 2 in front of HCl. But that also changes the number of chlorines. Okay, that's no big deal, because now let's balance the chlorines. There's 2 on the left, 3 on the right. They're both a common factor of 6, so let's get 6 chlorines. To do that, we're going to toss out the 2 and put a 6 in front of HCl. And that changes the hydrogens as well. Hydrogens are now 6 of them, and chlorines, there are 6 of them. Let's balance the hydrogens again. Hydrogens on the right now have fewer, so let's put a 3 in front of H2. That gets the hydrogens balanced. And chlorines, let's turn that into a 6 by putting a 2 in front of AlCl3. So now that we have 6 chlorines on the right. Great, so we've balanced the hydrogens and the chlorines. Only the aluminums are left. But since we put a 2 in front of AlCl3, we now have 2 aluminums on the right and 1 on the left. They're not quite balanced, but that's easy enough. We'll put a 2 in front of Al and we'll balance the chemical reaction. Now let's try a third example. This is possibly the most difficult. We'll put a table below it and keep track of each element on each side of the reaction. There are 2 of each on the left, and there's 1 carbon, 2 hydrogens, 3 oxygens on the right. Don't forget that oxygen comes from both water and carbon dioxide for a total of 3. Let's balance the carbon first by putting a 2 in front of carbon dioxide. That also changes the number of oxygens. There are now 4 oxygens with carbon dioxide and 1 oxygen from the water for a total of 5 oxygens. The hydrogens are balanced, so now let's move on to the oxygen balancing. We'd want to put a number in front of O2, but there's no one number that we can put in front of O2 that will change it to 5. Instead, let's get rid of the 5 by doubling the entire reaction. Let me show you how that's done. I'm going to put a 2 in front of the acetylene, a 2 in front of the water, and a 4, doubling 2, in front of carbon dioxide. Of course, that will change all our numbers below, but that's no big deal. Let's keep track of things. There's now 4 carbons on the left and 4 carbons on the right. Hydrogens too have changed. 4 hydrogens on the left, 4 hydrogens on the right. And finally, oxygens have changed, and this is most important. We now have 8 oxygens from carbon dioxide and 2 oxygens from water for a total of 10 oxygens. And now we can put in the last coefficient. What number do we put in front of O2 to balance it? A 5. Putting a 5 there gets us 10 oxygens on the left and 10 oxygens on the right. In other words, when you're trying to balance a chemical reaction, Draw a table, keep track of elements, and don't be afraid of going back and forth until eventually you discover them all.